Namaste everyone. Let us start today's session with a small recap. So we started circles chapter and we learned main two theorems, that is theorem 10.1 and 10.2, and also we completed exercise 10.1 and 10.2 from question number 1 to 6 we completed, which are based on completely the two theorems. Now let me start today class by recalling the two theorem statements. So what is the first theorem we learned? We learned that the radius of a circle is perpendicular to the tangent at the point of contact. So this is very important theorem where we apply this to solve the questions. And the second theorem is we proved that the tangents drawn from the external point are always equal in length. So we can draw two tangents from the external point and those two tangents length will be equal. So keeping these two statements in mind, let us continue today's class. So this is a question number 7, it's exercise 10.2. Let me read the question. Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. So before I start the solution of this question, let me explain what is the meaning of coencentric. Coencentric means circles, that is it can be two or more circles having same center. Means if the center of the circle is same, if you draw circles, as many circles as you can draw, you can see that these circles having same center. Because these circles have same center, we call these circles as coencentric circles. And are of radius, that is a bigger circle is of radius. This circle is of radius 5 cm and another circle, that is small circle, is of radius 3 cm. He is asking find the length of the chord of the larger circle. So here you can observe AB is the chord which touches the smaller circle. Means AB is the chord for larger circle and which is touching the smaller circle at P. That is at a point P. You can see that this P is called point of contact for this circle. And observe, when AB is a chord for the bigger circle, then what will be AB for smaller circle? Just observe and tell what will become for the smaller circle. The same AB is a chord for larger circle because it is meeting at 2 points, and the same line segment AB is a tangent for smaller circle. So it is a tangent for small circle, and where you can see this P is called point of contact. And by theorem 10.1 you know that this is a radius of smaller circle which is, he has given that it is 3 cm, and this is the radius of bigger circle, he has given 5 cm. And from theorem 10.1 I can tell that this is perpendicular, means OP is perpendicular to AB. So keeping in this mind, let us find the length of AB. How to find the length of AB? Just see this. If I find the length of AP or PB, then I can double it to find the length of AB. So what is the concept behind this? Means before I find the length of AB, I should find any one, either PB or AP, because these two becomes a right angled triangles. Using Pythagoras formula, I can find the length of PB because you know this hypotenuse 5 cm and perpendicular line is 3 cm. So using Pythagoras formula, I can find the length of PB. If you double it, this becomes AB. So how can you tell that if I add AP plus, means if AP and PB are equal? I have to prove that. Without proving, we can't tell that AP and PB are equal. So for that, let me take the congruence concept. Two triangles, you can see AOP and BOP are the two triangles. Now let me prove that these two triangles are congruent. So to prove any congruent, we need three matching pairs. Just look at the diagram. The first matching pair you can see AO equals to BO because both are radius of bigger circle and he has given that 5 cm. So AO equal to BO, which is radius, and he has given it is 5 cm. So this is one matching pair we got. And the middle you can see OP and OP is common for both the triangles. So this becomes the common, that is second matching pair for this. And the third matching pair, as you know that OP is the radius of smaller circle and AB is a tangent for the smaller circle and P is a point of contact. So by theorem I can tell that OP is perpendicular to AB. So I can tell that angle OPA equals to angle OPB equals to how much? 90 degree. So I got the third matching pair. Now I can tell that these two triangles are congruent by side angle side. You can observe here, this is one side and this is one side. This is not by side angle side, this becomes RHS. Why? Because you can see here OA and OB are the hypotenuse and this is 90 degree and this is side. So these two triangles are congruent by RHS congruent condition. So, and you know that whenever two triangles are congruent, so the other remaining parts will become equal by CPCT. What is the meaning of CPCT? Corresponding parts of congruent triangles. So what I need exactly here, many parts are equal, but what I need to show that AP equal to BP. So I proved that AP equal to BP by CPCT. Now we proved that by congruency we proved AP equals to BP, means AP and BP, these two parts are equal. Now it is very easy to find the length of the chord. So if I find any one, PB or AP, if I double it, then we can find the length of the chord. So now any triangle, because both the triangles are same, pick any one triangle. You can see that OPB is a right angle triangle which is right angle at P. And he has given that OB is 5 cm and OP is 3 cm. Now I need to find PB. So apply the Pythagoras formula. So he has given in triangle POP angle P equal to 90 degree. So hypotenuse is OB. OB square equal to OP square plus PB square. Substitute the given values. OB is 5. 5 square equals to, and OP has given, that is radius of smaller circle, 3 square plus PB square. 5 square is 25. Bring this to left side, minus 9 equal to PB square. So PB square equal to 16. PB is root 16, that is 4 cm. Now I got this length of PB as 4. If this is 4, this is also 4. So now I got length of AB. Just now we proved that AP and BP are equal. So I can find the length of the chord AB equals to twice PB. So 2 into 4, that is 8 cm. So we can conclude that length of this chord is 8 cm. Let's move for the next question, that is question number 8. Children, this question is very important for 3 marks. It's very important, and what I am solving today's session, that is from question number 7 to till the end of this exercise, all these questions are very important for 3 and 4 marks. Especially this you may get for 3 marks. So let us read the question. Given a quadrilateral ABCD is drawn to circumscribe a circle, prove that AB plus CD equal to AD plus BC. So let us see the question in detail. He has given that ABCD is a quadrilateral, is drawn to circumscribe. Means what? Whenever they use the word circumscribe, means a quadrilateral is around the circle. Means circle is inside and the quadrilateral is outside. So quadrilateral is circumscribe to the circle. That is the meaning of the question. And we have to prove that AB plus CD. You can observe AB plus CD. AB and CD are opposite sides of this quadrilateral. You can see they are on left side. And the other two sides equal to AD plus BC. These are opposite side which are on right side. So the sum of these two opposite sides is equal to sum of these two opposite sides. So I need to prove this. Now, to prove this, what is the main criteria? Which theorem you can use? So here I can't use theorem 10.1 because there is no radius here, I can't draw. Even there is no required for construction. So using this 10.2, what is theorem 10.2 says? The tangents drawn from external point are always equal. So you can observe here AP and AS. AP and AS are tangents drawn from the point A. So I can tell that AS and AP are equal. Understood? So this is an external point. AS and AP are the two tangents drawn from external point. So these two are equal. Similarly, from D, you can see these two tangents are equal because it's drawn from D. DS and DR are the two tangents drawn from D. So these two tangents are equal. Similarly, C is a point, external point. CR and CQ are these two tangents drawn from So point C, so these two tangents are equal. Similarly, here you can observe B is an external point. So BQ and BP are equal because they are drawn from the point B. So here I have written whatever I explained now, you can just write here clearly. We proved that AP equal to AS, this corner, and from this corner you can tell that DS equal to DR, and from this corner you can write BP equal to BQ, and from this corner CR equal to CQ. So here I have all the four corners, the tangents are equal. I have written here, and take this as 1, 2, 3, 4. What is the reason behind? Since tangents drawn from external points are equal. Now what I should do to get the answer? You can observe the answer. On the left side you have opposite sides. So be careful when you write this 4. When you write this 4, you can see AP, PB, DR and CR are the parts of the opposite side. AP, PB. So you can see AP is this part, a part of this line, and PB is a part of this line segment, and DR and CR. You can see DR and CR are part of this line segment which are opposite to each other. So you have to write in that way only. If you write this here and this here, again you have to reverse here to add to get the answer. So better parts of opposite sides you write on one side, and parts of the other two opposite sides you write on the other side. Then when you add, it will be easy to get the answer. Now adding 1, 2, 3, 4, we get AP, left sides you add on left side, and right hand side add on the right hand side. Now you can see AP plus PB. See the diagram? AP plus PB together is what? AB. Similarly, DR plus CR. So together is CD. So that's why I told you, write opposite sides. These four parts are the parts of opposite sides of the line segment. So write on one side, then exactly you get the answer. AB plus DR plus CR is nothing but CD, and the other side AC plus, you cannot add these two. So AS plus DS, you can observe here AS plus DS. AS plus DS is what? AD. BQ plus CQ equals to BC. So hence we proved that when a quadrilateral is circumscribed a circle, so we can see the four corners tangents are equal, and we can prove that AB plus CD equals to AD plus BC. This is proved. Let us continue with another question, question number 9. This question is also very important for 4 marks. So it is very important. In this chapter you get only one question, either it is 3 marks or 4 marks. From question number 8 to till the last, any one question is compulsory. So here let us read the question. XY and X dash Y dash are two parallel tangents. What is meaning of parallel tangents? You can see only two tangents can be drawn which are parallel. We already proved it in the previous questions. So you can see here XY and X dash Y dash are parallel to each other. To a circle and another tangent, one more tangent, that is AB. You can see here tangent AB with a point of contact C. Means when you draw this tangent, here you have to mark this as C. So be careful, diagram will not be given. By seeing the question you have to draw your own. So draw AB which meets the circle at C, which is called point of contact. With a point of contact C intersecting XY. So this AB intersects XY at A and X dash Y dash at B. So this is given and this is the diagram. So we have to prove that angle AOB equal to 90 degrees. So where is AOB? So before that AOB had to join A to O and also join B to O, join C to O. Now I have to prove that this angle is 90. You can observe here in triangle AOB. So observe in triangle AOB, I have to prove that this angle AOB is 90 degree. So whenever we want to prove any angle, we need to go for sum angle property. So in a triangle, you know that sum of three angles is 180. So that concept I have to go. Now I have to consider AOB and apply sum angle property to find angle AOB. But I don't know this second angle and I don't know the third angle also. So for that, we go for some congruence condition to prove now. So here I marked this as 1 and this as 2. Here you can see 3 and 4. Instead of reading three letters, so you can use the numbers and be careful. when you mark this in a diagram, then only you can use in the question. Otherwise, you cannot use this. So now let me prove that these two corner triangles are congruent to each other. So which are the triangles there? AOP and AOC. Observe these two triangles. AOP, AOC. So can I prove they are congruent? So see the three matching pairs. You can see PA and CA are equal. Why they are equal? They are tangents drawn from external point. And you can see here OA is common. Second matching pair. And OP equal to OC. You can see they are radii. So they are equal. So here I have written all the three matching pairs. AO equal to AO, that is common. AP equal to CP because tangents drawn from external point. OP equal to OC because they are radii. So I got three matching pairs. Hence I can prove that these two triangles are congruent by which congruent condition? By SSS. So if these two triangles are congruent, then the remaining corresponding parts will be equal. So we are not bothered of other corresponding parts. So we need these two. So can I tell, because I proved that these two triangles are congruent, can I tell angle 1 equals to angle 2? Yes, angle 1 equal to angle 2 by CPCT. So I got those two corner angles are equal. That is angle 1 and angle 2 are equal by CPCT. That is corresponding parts of congruent triangles. But I don't want 1 and 2, and only we have to concentrate the angle which is in the triangle AOB. So you can see this triangle AOB. AOB. Just concentrate this triangle. I need to prove that this is 90. So for that I need this 2 angle and also I need this 3 angle. Now I have to correlate. So what I got now, 2, I proved that 1 equal to 2. But I don't want 1. So let me write 2. If 1 and 2 are equal, can I write angle 2 equals to half of this full angle? This is natural. Whenever a line bisects an angle, each smaller angle will be the half of the bigger angle. So I can write angle 2 equals to half of PAC. Similarly, what is PAC? PAC can also be written as PAB. So I got angle 2 equals to half of angle PAB. Now I got one angle, that is 2. Now let us find similarly the another angle which is 3. So now we proved already that these two triangles are congruent, and we already proved angle 1 equals to angle 2, and we got angle 2 is half of this full angle. How will you read? Angle 2 equals to half of PAC, or you can write PAB. So what is this concept actually? If you see, if this is an angle AOB, I am taking one just example and explaining what is this. If this is a bisector, if this is 1 and 2, if angle 1 and angle 2 are equal, means suppose if this is 30 degree and if this is 30 degree, mark this as C. If these two angles are equal, I can tell that each angle equals to half of the bigger angle. So that I am taking here. So you can see 30 is equal to half of AOB. 30 is what? AOC or BOC can be written as half of AOB. When any two angles are equal, the each smaller angle will be always half of the bigger angle. So same concept will be applied for line segment. When we bisect a line segment, when a point is a midpoint of a line segment, the each two sides will get equal sides. Each part is equal to half of the bigger line segments. In the same way here you can apply, the each smaller angle will be equal to the half of the bigger angle. So since we proved, if you apply this concept here, we proved that 1 and 2 are equal. So I can tell angle 1 equals to half of PAC, or also angle 2 equal to half of PAC. Then why I took only 2, why I didn't take 1? Because so our main idea is on this triangle, that is AOB. So we have to apply some angle property for triangle AOB. So that's why we don't want 1, so we have to consider as 2. So I can write angle 2 as half of PAC or PAB. So till now I proved. Similarly, how I proved that these two triangles are congruent? I can tell directly that these two are also congruent by SSS. So I have written this directly. Similarly, triangle QOB is congruent to COB. So already one corner triangles you proved they are congruent. So you can write that these two triangles are also congruent by the same condition, that is SSS, and similarly I can prove that angle 3 equal to angle 4 by CPCT. So if 3 equal to 4 by CPCT, the same what I applied there, so if you apply here also, angle 3 equal to 4. Now tell me whether I should write 4 equal to half of QBA or 3 equals to half of QBA. So 4 we should not take. Why? Because 4 is not in the triangle AOB. So I need 3. So I can write angle 3 equals to, just observe here, angle 3 equals to half of this angle. So which angle? You have many letters here, don't get confused. You can write QBC or you can write QBA also. But I am writing QBA. So I got angle 3 as half of QBA. So mark this as B. Already we have used the numbers there 1, 2, 3, 4. So mark them as B. And before I have marked as A. Now I got angle 2 and I got angle 3. So this is the main concept behind this to find the third angle. So now I am going to apply the sum angle property. So in triangle AOB, angle AOB plus angle 2 plus angle 3. You can observe here angle AOB plus 2 plus angle 3 equals to 180. Now angle AOB write as it is because our main concept is to find angle AOB. Plus what just now we found out what is 2. Angle 2 we got half of PAB plus angle 3 here we got half of QBA equals to 180. Now take common here, half you take common, so you got in the bracket PAB plus QBA. So as you know that in a triangle out of 3 angles, if I know 2 angles, then only I can find the third angle. So now let us try to find these 2 angles. Let us find what he has given. Just go back. He has given XY and X dash Y dash are parallel. So when these 2 lines are parallel and this is a transversal, you can see here XY and X dash Y dash is parallel and AB is a transversal. Because AB is transversal, this corner angle and this corner angle becomes co-interior angles. As you know that these 2 lines are parallel and sum of co-interior angles is 180. So I can write here PAB plus QBA. You can see here PAB plus QBA. You can see U shape. So these 2 angles sum will be always 180. So now I got here, you can give the reason that XY is parallel to X dash Y dash. Therefore PAB plus QBA is 180. Why? Because sum of co-interior angles is 180. So just substitute this now. This is mark it as D. Substitute this D in C. So write AOB as it is plus half write as it is and this sum we got as 180. So now cancel half, that is 2 90s are 180 and bring this 90 here. So angle AOB equals to 180 minus 90. So I got angle AOB as 90. So in this way, here we have taken the many concepts that we proved. We have taken the tangents drawn from external point are equal and we went for congruence concept and also we went for sum angle property and also we use the concept of parallel lines. So many concepts we are using here, very important question which you get for 4 marks. So in this way we proved that angle AOB is 90 degree.